Hi students, welcome to lesson 6 parallel lines. So we are studying chapter 11 three-dimensional geometry second PUC. We have completed 5 lessons so far on straight line. In the last class I have introduced a new concept called skew lines. So in space there are three possibilities which we have studied. Let me recall first what we have studied. See, nature of lines in space, this is what I introduced in the last class. Three-dimensional lines, there are three cases. First one is two lines may intersect, so intersecting lines. And in the diagram you have to understand, both lines are intersecting means they belong to one particular plane. Therefore, once again they are coplanar. The moment two straight lines are coplanar, you can also treat them as two-dimensional lines. Then second one is parallel lines. And remember, once again, parallel lines are also coplanar because you can find one plane which contains these two lines. Therefore, once again they are coplanar, so you can treat them as two-dimensional straight lines only. So this is a second one. And in the last category, that is skew lines, two lines are such that they are called skew lines because they are neither intersecting nor parallel. And in the last class we have seen how to find the shortest distance between two skew lines. Now consider the middle one, that is parallel lines. See, whenever two lines are parallel, the distance between them is constant. Therefore, what we are doing in this class is distance between parallel lines we are deriving. So that we will be able to find the distance between the parallel lines using the formula. That is what we are going to do in this lesson. But before proceeding, let me make one thing clear. Given the equation of two lines, we can decide whether they are parallel or not. See, this is the thing you have to understand. Consider the equation r equal to 2i minus 3j plus k plus lambda times 2i plus j minus 3k. Here in the first line, the first vector 2i minus 3j plus k refers to the position vector of the point on the line. And the second one, lambda times, that is b1, 2i plus j minus 3k, that is b1. So that's the vector. So that means the given line is parallel to the vector 2i plus j minus 3k. So this is the understanding. Now come to the second line. Say r equal to 2i plus 3j plus 5k. That means the first vector is the position vector of the point on the line. And mu times, so constant is mu here, 4i plus 2j minus 6k, that is the vector b2. So and the line L2 is parallel to the vector b2. Therefore here you can take b1 as 2i plus j minus 3k and b2 as 4i plus 2j minus 6k. What is the speciality here? Now if you closely look at b1 and b2, they are parallel vectors because the direction ratios are parallel, proportional. You can see 2 by 4. I component is 2 and 4. 2 by 4, 1 by 2. J component is 1 and 2, 1 by 2 once again. K component is minus 3, minus 6. Once again it is 1 by 2. Therefore, B1 and B2 are parallel vectors means lines also must be parallel. Therefore, after observing the given two lines, you can immediately decide whether they are parallel or not. So what is the condition? The vector b1 and b2, either they should be same because constant changes, lambda and mu changes. Sometimes vector may be different, but they are proportional. So this is the understanding we should have before we proceed. Therefore, remember, two lines which are parallel, they are also coplanar. This I made it very clear. Let us proceed. Distance between two parallel lines. So we can take it as a theorem. The distance between two parallel lines are equal to a1 plus lambda b and r equal to a2 plus mu b is given by, this is the formula, d equal to b cross a2 minus a1 divided by magnitude b. Then of course you have to take mod because distance should be always positive. This is the understanding. Now look here, the first line r equal to a1 plus lambda b, b is same. Second line is r, a2 plus mu b, so b is same. proof. Let L1 be the given vector R equal to A1 plus lambda B. So this is L1, and then L2 be the second line, that is R equal to A2 plus mu B. So this is L2. So these two are parallel because vector B is same. Now let S be the point on L1 with position vector A1. So on L1 mark a point S whose position vector is A1. Then let T be the point on L2 with position vector A2. So mark a point A2 T on L2 whose position vector is A2. Now join ST. So now draw TP perpendicular to L1. So TP is perpendicular to L1, and let us say distance TP is D because that is the symbol we are using. So now TP is D. So remember here the line TP is perpendicular to both L1 and L2. So let theta be the angle between ST line segment and SP. So you can see here the angle between SP and ST is theta. So now then the theta is the angle between ST vector and B also, because SP line segment is on the line L1. So the direction of SP vector is same as direction of the vector B. Therefore, theta is the angle between the line segment ST and SP. That also means it is the angle between the vector ST and vector B. Why vector B? Because line L1 is parallel to vector B. So therefore, now consider this B cross ST. So that will be equal to, by definition it is magnitude B into magnitude ST into sine theta into unit vector N, where N is the unit vector perpendicular to both B and ST, or L1 and L2, both are one and the same. Now ST is actually A2 minus 7. You can see in the diagram, position vector of S is A1, position vector of T is A2. Therefore, vector ST must be equal to difference of the position vector, that is A2 minus A1. Therefore, substitute B cross A2 minus A1 will be equal to magnitude B, then magnitude ST, then sine theta into unit vector. So this is the first thing you have to remember. Now magnitude vector B cross A2 minus A1, that will be equal to, if you take the magnitude, then right side also you have to take magnitude only, magnitude B magnitude ST, because n unit vector magnitude of unit vector is 1, therefore it is ST sine theta. The moment I write ST sine theta, I need not write magnitude because ST is the line segment length, sine theta is anyway positive. Therefore we can, after taking the mod, please observe left side it is magnitude of B cross A2 minus A1, that is equal to magnitude B ST sine theta. This is the thing. Now look here, what is ST sine theta? So TP equal to ST sine theta, because look at the diagram in the angle triangle STP. What is sine theta? Sine theta will be equal to opposite side TP divided by hypotenuse ST. Therefore, what is TP? So TP will be equal to ST sine theta. Therefore, in the expression, ST sine theta will be equal to TP. This is very important. Let us proceed. So this you can write now, magnitude B into TP. So I am repeating again, ST sine theta you can replace by TP. So this is the first thing you have to observe. Now what is TP? So it is magnitude B into D, because you can see here in the diagram TP is nothing but D. Therefore, we can say D equal to magnitude, that is magnitude of b cross a2 minus a1 divided by magnitude b, that is cross multiplying, that is taking magnitude of b vector the left side, you get d equal to a magnitude of b cross a2 minus a1 divided by magnitude b. This is the formula for finding the distance between parallel lines. So let us proceed. This is the proof. Example 1. Find the distance between the lines r equal to I plus 2j minus 4k plus lambda times 2i plus 3j plus 6k and r equal to 3i plus 3j minus 5k plus mu times 2i plus 3j plus 6k. The moment you observe the equation of the two lines, immediately you can decide one thing. These two lines are parallel because in the first line lambda times 2i plus 3j plus 6k. In the second one it is mu times same vector 2i plus 3j plus 6k. So the lines are parallel. So this is the first thing you have to observe. Now here r equal to 2i plus 3j plus 6k and a1 is I plus 2j minus 4k and a2 is 3i plus 3j minus 5k. Therefore, first I'm sorry, there is a change here. B is 2i plus 3j plus 6k, B, please note, and a1 is the position vector of the first line, that is I plus 2j minus 4k, a2 is 3i plus 3j minus 5k. Now first let us find a2 minus 7 because we need this one. So find it. a2 minus 7 is, a2 is 3i plus 3j minus 5k minus I plus 2j minus 4k. So simplify. So you get 2i plus j minus k. Then find b cross a2 minus 7 because we need this one. So what is b? B, first ijk, of course you know how to find the cross product, ijk. Then what is b? B is 2 3 6 because vector b is 2i plus 3j plus 6k, therefore b is 2 3 6. Then second one is, of course, a2 minus a1 you have determined, that is 2 1 and minus 1. Simplify this one, determinant. So I have directly written it is minus 9i plus 14j minus 4k. So this is the cross product. Now what is the formula? D equal to, now it is very simple, mod of or magnitude of b1 cross a2 minus a1 divided by magnitude of b, just substitute. So this will be equal to magnitude of, we have to take minus 9i plus 14j minus 4k divided by magnitude b, you have to calculate. Magnitude b formula also you know. Therefore simplify. So we get, after simplification, actually it is 9 square plus 14 square plus 4 square in the numerator, square root. Below it is 2 square plus 3 square plus 6 square, square root. So the final answer is square root of 293 divided by 7. So this is the distance, not shortest distance, it is the distance between the two given parallel lines. So this is the first example. Now let us go to exercise 11.2. Students, please note, this is the last lesson on straight lines. Next lesson we are going to start planes. So here a few problems are remaining in exercise 11.2. In this lesson let us complete all different types of problems. Whatever problems are repetitive, that I have left, that you can practice as homework problems. So the example 14 let us take. Find the shortest distance between the lines L1 and L2 whose vector equations are r equal to I plus 2j plus k plus lambda times I minus j plus k and r equal to 2i minus j minus k plus mu times 2i plus j plus 2k. We have already done one question, but let us do one more question. A1 equal to I plus 2j plus k. This is the position vector of the point on the first line. Then A2 equal to 2i minus j minus k. This is the position vector of the point on the second line. And B1 is I minus j plus k. And B2 is 2i plus j plus 2k. See, in any such question, first you have to identify what is A1, what is A2, what is B1 and what is B2. Write them. Then what is required? formula. What is the shortest distance formula? D equal to B1 cross B2 dot A2 minus A1 divided by magnitude B1 cross B2. So this is the formula. So we have to calculate two things. One is B1 cross B2 you have to find, then A2 minus A1 we have to find, then you have to take the dot product. So these are the three important things. Now let us proceed. First we will find B1 cross B2. What is the method? Determinant ijk, then B1 vector component 1 minus 1 1, B2 vector component 2 1 2. So simplify. Simplifying, it is I into minus 2 minus 1 minus j into 2 minus 2 plus k into 1 plus 2. So simplifying, you will get minus 3i plus 3k. Now what you have to do? Magnitude also you can find and keep it ready. So this will be equal to 9 plus 9 under square root, that is 3 root 2. Then next, what you have to calculate is B1 cross B2 dot A2 minus A1 you have to calculate. So let us do it. B1 cross B2 you know already, it is minus 3i plus 3k. Then A2 minus A1 I have written here, square bracket, 2i minus j minus k minus I plus 2j plus k. Simplify further, you get minus 3i plus 3k dot I minus 3j minus 2k. Simplify dot product. So this will be minus 3 minus 0 minus 6, that is minus 9. Therefore, you have to find now D equal to, substitute the value. So this will be equal to 3 root 2. Then numerator it is 9 because we have to take mod. So minus 9 becomes plus 9. So this of course you can keep as it is, or you can also simplify. For example, you can take root 2 multiply and then you can simplify like this, 3 root 2 by 2. Both are one and the same. Normally tradition is the surd should not be in the denominator, that is square root, irrational number should not be in the denominator. Therefore multiplying by root 2 we get 3 root 2 by 2 is the final answer. So this is the first question in the exercise in this lesson, that is example 14. Next, example 15. Find the shortest distance between the lines. Here there is a small change. So given equations are in Cartesian form, not in vector form. So the first one is x plus 1 by 7 equal to y plus 1 by minus 6 equal to z plus 1 by 1. That is second line is x minus 3 by 1 equal to y minus 5 by minus 2 equal to z minus 7 by 1. So Cartesian form. So let us do it. Given, what is the equation L1? L1 is x plus 1 by 7 equal to y plus 1 by minus 6 equal to z plus 1 by 1. L2 is x minus 3 by 1 equal to y minus 5 by minus 2 equal to z minus 7 by 1. You can use the vector formula and identify what is vector A1, vector A2, B1, B2. That is one method. Or you can also use Cartesian formula, because I have given you what is the Cartesian formula for shortest distance. So here this is the formula, if you remember, it's a very big formula. Determinant x2 minus x1, y2 minus y1, z2 minus z1. Then you have to take a1, b1, c1, a2, b2, c2. This is the determinant value. Therefore, you have to take mod only. Then below, please remember, if you want to use Cartesian formula, this is the thing, b1 c2 minus b2 c1 a square plus c1 a2 minus c2 a1 square, then a1 b2 minus a2 b1 square. How to remember this? So remember, here there is a cyclic repetition, that is b1 c1 b2 c2 c1 a1 c2 a2 a1 b1 a2 b1. So easy to remember, everything is under square, then square root. So here what is important is given equation L1 and L2, you have to identify what is x1 y1 z1 x2 y2 z2 and then a1 b1 c1 a2 b2 c2. This is very important. Let us see. See here, x1 is minus 1, x1 is minus 1 and y1 is minus 1 and z1 is also minus 1. See, the equation is x1, x plus 1 means x minus minus 1. So x1 becomes minus. Similarly, you can see x2 is 3, y2 is 5 and z2 is 7. This is the first thing you have to observe. Then you have to identify what is a1, b1, c1 and A2, B2, C2. If that is done, problem is solved. So what is A1 now? So you can see it is 7. Then B1 it is minus 6. And then C1 it is 1. Then A2 it is 1. Then B2 it is minus 2. And C2 it is 1. So once these things are over, problem is solved. Just substitute and simplify. So let us see. See here I have to find first x2 minus the determinant value I have to find, that is x2 minus x1, y2 minus y1, z2 minus z1, and then a1, b1, c1, a2, b2, c2. Substitute first. So we get this one. Determinant 3 plus 1, 5 plus 1, 7 plus 1 in the first row, because x2 minus x1 means 3 minus minus 1. Similarly, y2 minus y1 means 5 minus minus 1, like that. So second one, a1, b1, c1 will be 7 minus 6, 1, and a2, b2, c2 will be 1 minus 2, 1. You know how to expand the determinant, therefore you can find it. 4 into minus 6 plus 2, minus 6 and 7 minus 1, and all these things, students please note, you should do your own. It's just not just by observing, you should actually practice by writing your own answer. So it is minus 60, minus 36, minus 64, so that is minus 116. So the determinant value is minus 116, please note. Now let us proceed. So I have determined the value of the determinant, that is in the numerator. Now we have to calculate the square root of b1 c2 minus b2 c1 square, etc. So let us proceed. So now determinant value I have already found out, this is minus 116. Let us calculate b1 c2 minus b2 c1 square, c1 a2 minus c2 a1 square, and then a1 b2 minus a2 b1 square, and this will be equal to minus 6 plus 2 square. You can check 1 minus 6 square plus minus 14 plus 6 square. When you simplify, you get once again 116. Very interesting. And numerator it is minus 116, denominator it is 116. Therefore, what is d now? D will be equal to 16 by root 16, because mod you have to take, therefore you have to ignore the minus sign. So when you simplify, you get root 116, but you can write this because 4 is the factor, so you can take out. So it is 2 root 29. So this is the shortest distance between them. See the difference when you are using see this Cartesian form, formula is very big, but when you use vector form, formula is small, and there of course you have to remember b1 cross b2 you have to find. That is also determinant only, it is in terms of ijk, and then you have to find a2 minus 7 and then dot product, then magnitude of b1 cross b2. That is one method. Here it is not like that. You have to identify the component x1 y1 z1, x2 y2 z2, then a1 b1 c1, a2 b2 c2, then remember the formula, then substitute. Both are similar. So it is left to you whichever, but in examination sometimes using Cartesian formula you have to find, means you have to find only using Cartesian form, and using vector form you have to use vector form. So that is the difference. So hope you have understood everything in this lesson. As I told you, this is the last lesson on straight lines. It is not the last lesson on this chapter, last lesson on straight line. I have solved all the types of questions. Please solve remaining questions of 11.2. Hope you have already subscribed my channel. If not, please subscribe and share with your friends. Let us meet in the next lesson, that is lesson 7, with the new concept, that is planes. This is also very, very interesting. Till then, bye, take care.